So today I'm going to make a video for you about the review of finding area and volume, all the different things we've done based off of dx and based off of dy. So when you're following along, we're actually going to have a line going straight through our paper, and we're going to talk about how we solve the area with top minus bottom, how we solve the area right minus left, how we solve the volume when it's rotated about the x-axis, how we solve the volume when it's rotated about the y-axis, and things like that. So you'll get a nice overview of the entire unit. Now, I gave you two equations so far. We've got y equals the square root of x and y equals 1/2 x. So the first thing we want to do is we want to graph these things. So I'm going to get started with my graph. I'm going to go up to 4. I'm going to go up 2. So the square root, we have 0, 0, we have 1, 1, and we have 4, 2. So that's going to look like this. And then the graph of 1/2 x, it's at 0, 0, and it is at the point 4, 2. So it's a line that goes this way. Okay? So down here, this one is the 1/2 x equation, and up here it's the square root of x. Now, if we were looking over here at our y, it's going to be the exact same graph. The graph isn't going to change at all. But how we name the equations, or how we write the equation, that's going to change. So 0, 0, 1, 1, 4, 2. And I, like Mr. Taylor talked today, oops, I missed that little dot. And when I say today, I'm making this video on Monday, depending on whenever you're looking at it, but that's why I said today. And then, of course, we have the 0, 0, and the 4, 2, and this is the line right here. It's always easier, like what Mr. Taylor said today, to graph in y equals. And then once you do that, you can change them to x equals. So if I square both sides, y squared is equal to x. So that means this is a y squared equation right here. And then, of course, if you have 2y is equal to x, because you multiply both sides times 2, that's this equation down here, 2y. So now you've got your dx stuff and your equations for the dx's and your dy things and your equation for dy. Because remember, if you're doing everything in terms of y, you care about your y intervals. So we're going to care about this 0 and this 2 for our intervals, 0 and 2. When you're dealing with dx, you're going to care about your x intervals. So we're going from 0 to 4. 0 to 4. So just keep in mind, if you're doing dx, you need your intervals along your x-axis. If you're doing dy, you need your intervals about the y-axis. Okay, so let's go ahead and get started. The first thing we're going to take a look at is we're going to take a look at the area. So we're going to find the area of this figure, and we're going to do it both ways. We're not going to actually solve it and put it in our calculator. We're just setting it up. On this upcoming test, you can use your calculator for everything. So you will have to show your work. You'll have to show your graph. You'll have to show your intervals and your integration, and then you can just put it in your calculator to get the answer. So looking at the area, you're going to integrate top minus bottom. So when we're doing area, it's just top minus bottom. So in this case, it'll be 0 to 4 of our top equation minus our bottom equation, dx. Now we went from 0 to 4 because those are the x values. The top equation was the square root of x. The bottom equation was the 1/2 x. And so you put it into your equation. Now, if you were looking at it in terms of dy, maybe it's because you have to. Maybe it's because the equations were x equals. And if they were x equals, you have to go this way in dy. And so you're going to do right minus left. So this time when we set up the integration, it's going to be 0 to 2. Because again, remember, we need our y intervals. The right equation is going to be our 2y equation. minus our left equation, which in this case is y squared, and then dy. Now, if you were to put these in your calculator, I haven't tested it, but if you were to do it, those answers should be very, very similar, if not exactly the same. They might be a little off by a couple tenths or 100ths. All right, so let's say we're taking the volume, can't spell, the volume about the x-axis, okay? So the volume about the x-axis. Well, when you do volume, you remember that you're going to have outer squared minus inner squared. And that's going to be over here as well, outer squared minus inner squared. You also, and this would be about the y-axis, okay? You also need to remember that pi needs to be in when you rotate. So if you ever see anything that says rotate, don't forget the pi. So we have a pi on the outside. We're going to go from 0 to 4. Now, if we're rotating about the x-axis, remember you have to figure out which one's the outer and which one's the inner. And now you can see my hand. So if my pointer finger is that square root of x, and then my pinky is the 1/2 x, and I rotate this way. Notice how my pinky is on the inside, and my pointer finger is the one that's coming on the outside, which means this one's the outer, and this one's the inner. So if I do outer squared minus inner squared, it would be set up that way. Pi from 0 to 4 of square root of x squared minus 1/2 x squared dx. Now, if I rotate about the y-axis, so I'm rotating about the y-axis. Well, this time, my pointer finger is this one right here, which would be the 2y, and my pinky would be this y squared. If I rotate this way, again, look, which one's going to be on the outside and which one's going to be on the inside. Now, I know this makes kind of a funny little picture, but this one is the one that's going to become on the outside. If we were making like a circular thing, this one's going to be on the outside, this one's going to be on the inside. Think of that thing we were talking about at the Living Museum where you put the quarter in and the quarter goes around and around and around. This is on the inside of it, this is on the outside of it. So if we have our pi and our integration from 0 to 2, outer squared would be 2y squared minus inner squared, which would be y squared squared dy. Now, I want you to take a moment to take a look at the things that we have in common here, okay? Our intervals, when we were doing dx's, are the same, 0 to 4 is 0 to 4. The difference here is this one doesn't have a pi because it doesn't rotate. This one does have a pi, it does rotate. Now look, outer is the same as the top. Inner was the same as the bottom. Same thing over here. Look, 0 to 2, those were our y intervals. 0 to 2, those are our y intervals. Our inner squared is the same as the one that was on the right. Our outer squared is the one that was on the left. But notice we have the squared extra. We didn't have the squared when we were doing area. Because remember, volume is based off of the area of a circle, which is pi r squared. So that's where the pi comes from, and that's where the squared stuff comes from. Okay? All right, so next let's look at volume about the line y equals 4. Okay? About the line y equals 4. Well, because we're going about a line, we have to have that outer distance and that inner distance before we can go ahead and we can do our equations. So what we have to do is outer, we're looking up here at outer, that's the square root of x, and we're rotating somewhere way up here at y equals 4. That's where we're going to do our rotation. So when we're doing that, it's actually going to change our outer and our inner. We've got to be careful because now we're rotating, and I'm going to make my pointer finger this 1/2 and then my pinky the square root. We're going this way. So if we're going this way, we're rotating the opposite direction. So that makes this one now the outer, and this one now the inner. And we have to say, well, what's 1/2 x minus the 4 to get our distance from that 1/2 x equation to the point of rotation? So the outer is going to be 1/2 x minus 4, which we don't have to do anything to. That's kind of fun. Our inner distance is the distance from the square root of x to 4. So it's the square root of x minus 4. Now again, remember, like we talked about in class today, if you have these switched, if you have 4 minus 1/2 x and 4 minus the square root of x, you'll still get the same correct answer, because we're going to square those values anyway. Now, to set it up, we've got our pi. We have our 0 to 4. That's been the same all the way down. Now we have our outer value squared minus our inner value squared. And that's how we would set up a volume about y equals 4. Now, what if we were doing volume about x equals 6? Okay, well, if we're looking up here, the volume about x equals 6, well, now this one here, this one is a vertical line, which is just like the y-axis, so that's why we've got to do dy. And we're going this way. Well, since I'm doing this way, now look and see which one's coming on the outside now. If my thumb or if my pointer finger is the one that's the y squared and my pinky is the one that's the 2y, and I'm going this way, my pointer finger is the one that's coming out. So since the pointer finger is the one that's coming out, it's the y squared. This is your outer. This one's your inner. So things change according to what you're rotating. If I was rotating over here, I was going this way, well then that 2y would be the outer. Same thing with this one. If I was rotating down here, then it would change the outer and the inner. Sorry, I was losing focus there. So you really do have to draw where it is you're rotating, and you have to practice with your hand to see which one's going to go on the outside, which one's going on the inside. So for this one, outer, get some more lead, the outer is going to be y squared minus the 6. Or you could do 6 minus y squared. The order doesn't matter. Here, let me see if I can get this higher so we can see our picture and our equations. Our inner is going to be the inner one, 2y minus the 6. Or 6 minus 2y. Does not matter which one you put first. Now we've got our pi, and we're going to integrate from 0 to 2 just like before. We have outer squared minus inner squared. Now, I don't know if we've talked about this or not. I know we talked about it with area. I don't know if we've talked about it with volume. Again, if you get a negative answer, it's because these two things have flipped orders. So what you need to do is you need to go back and you need to flip them back again. Don't just drop off the negative and not have this written correctly. Because remember, you're graded on do you have the right interval. On the AP test, they look at this and this is worth a point. So you want to make sure that you're used to writing it in the right order. Okay? And if you do write it in the wrong order, then just make sure to erase it or put a big X through it and write it in the correct order before moving on. Okay? All right, so let's look at volume about y equals negative 2. Let's look at what happens when we do that. Well, if I'm back up here at this picture, and I go down to y equals negative 2. Now I'm down here. Y equals negative 2. It's just like what I just talked about before. If I'm rotating about this one, look at what's on the outer this time. So I have to switch yet again. I have to make this top one the outer and this bottom one the inner. So you just have to really be careful about which way you're rotating. So this one, I'm going to have my outer is going to be, what, square root of x minus the negative 2, or square root of x plus 2. And my inner is going to be that 1/2 x minus the negative 2, or 1/2 x plus 2. And now that I have that, I know my setup, pi 0 to 4 of outer squared minus inner squared. Okay? And let's look at about the line x equals negative 3. Okay? So this time, instead of x equals 6, we'll be over here at x equals negative 3, so we're rotating this way. Well, look at what happens. If I rotate this way, now this is the one, that 2y is the one that becomes the outer. So I have to change again which one's the outer and which one's the inner. So you do have to be really careful about which way you're going. That's why I draw these lines and I have all these little turny things on them. So when I'm coming down here, and I've got my outer, we said it was 2y minus that negative 3, or 2y plus 3. And that inner would be y squared minus the negative 3, or y squared plus 3. So now, again, we can easily write our problem. Okay, so we've got our pi from 0 to 2 of 2y plus 3 squared, which is the outer squared, minus the inner squared, y squared plus 3 squared, dy. Okay? All right, so now we got to look at our cross sections. Okay, our cross sections. Do I want to write on that? I'll just get a new sheet of paper. It's easier. Cross sections perpendicular to the x-axis. Okay? Now, we've got to remember that our y, or our distance, is going to be top minus bottom. Now, this is the distance that your cross section is going to be. Now, I'm using this equation right here. I'm using these same equations. So I'm looking for the distance right here. Okay, what's my distance from top to bottom? Well, my top equation is the square root of x. My bottom equation is 1/2 x. So it's going to be y is equal to the square root of x minus the 1/2 x. Okay, so that's going to be my y distance. Okay, which would be maybe it would be the diameter of a semicircle. It would be the side of an equilateral triangle. It would be the side of a square. Okay, so let's look at number 1. Let's say that your cross sections are equilateral triangles. Well, the area for equilateral triangles is the square root of 3 over 4 and then y squared, or the side squared. So we integrate from 0 to 4 of the square root of 3 over 4, and then our y is this right here. So it's the square root of x minus 1/2 x quantity squared. Now, notice that there's no pi. Remember, with cross sections, we don't rotate anything. With cross sections, you just have your base, and then from your base, you have things coming out of it. So from your base, you're going to have a triangle coming out of it. So there are triangles all coming out of this, or there are squares all coming out of this. So it's coming up and off the page. So there's no rotation. So because there's no rotation, there's no pi. All right, number 2, let's say your cross sections are squares. This one's everyone's favorite because the area of a square is just side squared. So your y squared. Well, there's your y, because that was your distance from top to bottom. So you're integrating from 0 to 4 of that y squared. Done. Again, no pi, no rotation. Now, this one's the hard one. So let's say your cross sections are semicircles. Well, the area of a circle is pi r squared. Now, you want to do a semicircle, so that's half of the circle, so you want to divide that by 2. Now, this right here is your diameter. Well, you want to put radius in, so you have to do the diameter divided by 2. So again, let me show you the picture. This right here has your semicircle coming out. Okay, so if you have a semicircle, need more lead, you have a semicircle here, okay, this piece right here is this piece right here. Well, there's the center of your circle. So the whole thing is the diameter. We want just the radius. So there's that dot right there. I just want the radius. I want half of that distance. Well, half of that distance is half of the square root of x minus the 1/2 x. So I want my radius to be half of the square root of x minus the 1/2 x. Now that I have that, I can go ahead and I can do my integration. Now notice this one does have a pi. I'm going to pull that pi over 2 out in front. Why? Well, because it's just a number. It doesn't have an x or an r or a y or anything with it. So I can pull it out in front. And now I'll just do r squared, which is this ugly thing. Now, when you're putting this ugly thing in your calculator, I would use that fraction thing. I don't know that I have a calculator near me. Oh, I do. I do have a calculator near me. So what I would do for this is I would do my math 9, and I'm going from 0 to 4. Now, I do the parentheses, and then I'm going to say alpha, this little green alpha, y equals, and I'm going to get to that fraction bar. And then I've got the square root of x, the right arrow key, minus 1/2 x. Probably the easiest thing to do there is 0.5x, but technically what you could do, let me delete over, is you could do, let's see, alpha y equals, you could do 1 over 2 and then an x. So you could do that if you, like, let's say it was, I don't know, some, like 1/8 or something you don't easily know the decimal for. Well, go ahead and put it in, use that alpha y equals again, and that's divided by 2. And then come over here and do a parenthesis of the whole thing squared. Then you do your dx. Okay, and that would give me my answer. Now notice that I didn't multiply this by pi over 2. Well, I've got 2 choices. I could divide it by 2 and do math, enter, enter, and it doesn't come out, but 0.6.06666666666. Let's see. So I get 1/15 pi. You could do that. Or you could do that, let me pull my, that back up. You could just multiply the whole thing by pi over 2, and I might do parentheses there. And you get your 0.2094. Well, 1/15 pi is probably very close to the same decimal. I mean, it doesn't change until you get way out here. So it's for the most part, the same. Okay, and that, by the way, is 1/15 pi. They put the pi on the top. If they were dividing by 15 by the pi, they'd have to have parentheses around that 15 and that pi. Okay. All right, so if you have any questions on this review before you do this classwork worksheet, because remember it's not due till after spring break, please send me an email or ask me in class or something, and I can make sure and answer and clear up any problems that you might have. All right, I hope you have a wonderful day. Bye.